Recording. Yes, we have started our recording now. Good morning, friends. Today, let me share my screen. Today, we are going to see our session related to Python. That is, today is day 14. Python, Numpy, Matplotlib, Seaborn, Pandas. So today is the day 14 of our session. Python, NumPy, Matplotlib, Seaborn, Pandas. So today is the final session of Python. On no, so tomorrow no, we'll be going with machine learning. Introduction to machine learning, types of machine learning, and data pre-processing part will be handled by tomorrow. So our plan, day 1 to day 3 is statistics, day 4 to day 14 is Python, day 15 to day 29 is machine learning, day 30 to day 40 is deep learning, day 41 42 is natural language processing, day 43 to day 50 is reinforcement learning. This is our plan. And for the complete 50 days of artificial intelligence session. And so until yesterday, all the videos has been uploaded here. So if you go to bigdatahandson.com channel, you can also subscribe to our channel by clicking on the subscribe button here in this place. And you can also click on the bell icon. So daily basis our videos will be loaded here. And uh, until yesterday, that is part 13, all the sessions has been loaded to our YouTube channel. That is part 13 has been loaded, part 12 has been loaded, part 12 has been loaded. So until yesterday, whatever sessions has been raised is been took now. All session has been loaded from part 0 from part 1 to part 13 is been loaded. So today is part 14 of our session, that is modules part. At, and if you want to go to our website, it's bigdatahandson.com. Our contact number is 978-988-424 and also 9566182384. So these two is our contact numbers, and also our support mail ID is this. Whatever queries you have, you can call to our number 978-988-424. So now we shall start our session. Thank you.
So today we are going to see actually from today also we'll start machine learning actually. So today we'll see the tools for machine learning, the libraries in Python, the Matplotlib, NumPy, Pandas, Seaborn. These are the essential
Irfan, just be a
tools.
little bit louder.
Yeah. So these are the tools for machine learning actually. Let me. Okay. So for the tools, we want to install these libraries, this Matplotlib, NumPy, Seaborn. These are the third-party libraries. Okay. So we know that how to install the third-party libraries in Python. So I will show you three methods. One is I will show you to install the libraries in your machine, or you can use some softwares that provides these libraries. Okay, inbuiltly it will provide these libraries, and then I will show you without installation also you can do this programming, this type of machine learning and deep learning stuffs you can do in an environment. I will show you that. Okay, so first to install these libraries in your machine, so you have installed in Python. After installing the Python, you open just a command prompt or terminal in Linux. So you can just type pip install the library name, for example matplotlib. Okay, and then it will install the library. Okay, mine is pip3 actually. Okay, so and then it will install the library. Okay, so this way you can install all these libraries, or you can use another software that provides these libraries. Okay, the software is Anaconda. It provides all other tools and IDEs for code editing. Okay, it provides Spider, it provides Jupyter Notebook, and it provides Jupyter Lab, and more tools it provides. So these are the tools it provides actually. So this one. Okay, and you can install it from here, Anaconda installers for Windows, Mac, Linux. Okay, so I will show you. From today only we'll start using Spider actually, because the libraries are already installed there. So we'll use that Anaconda. Okay, so this software you can install and use. Otherwise, if you don't want to install any software in your machine, but still I want to run this code, you have an environment. If you have a Google account, go to your drive. So from this drive you can create a notebook, that is collaboratory notebook. Okay, there you can easily execute your programs without any installation. Okay, so I will show you, just it is loading the Anaconda, then I will show you that. Okay, now, yeah, so this is the Anaconda navigator. These tools are provided by Anaconda. So from this you can launch Spider actually. Spider is a good IDE for Python. Okay, now let's launch this. So from today we'll use this one actually, Spider. Okay, or else if you have installed VS Code, if you want to VS Code, no, you can change the environment actually, because this Anaconda navigator uses an environment called Conda. Okay, and inside that it has its own Python installed. Okay, so that you can, if you have Visual Studio Code, you can change the environment actually. So the Spider is loading. So now it's the Spider editor. Okay, so here you can this is an editor, you can write this code here, and the execution output will be shown in the console. It's called console, no, the output will be here. If you have any plots or any variables, you can see here. So these tabs, variable explorer and plots and files and help. If you want a function, if you have any function, if you want the help for the function, you can just press, for example, print is a function, and I'm pressing Control I. So it will show me the uh, help message or a document for this function. Okay, if you have any libraries, that one also will show actually. Okay, now wait. Okay, so I will show you the collaboratory. Okay, now so you are in the drive. Okay, in the drive you will see this new button, right? Click the new button and go to the more option. You will see collaboratory. If you don't see that, you can connect it from connect more apps. We'll just close some applications. This one. Okay, so here you can search the collaboratory. Or it's not showing me. I don't know why it is not showing me. So it will show you maybe I think Google Collaboratory here. After this you can see in the more option. Search in the connect more apps and then you can install it from there. Don't know why it's not showing to me. Okay, so after clicking on the Google Collaboratory, it will create a new notebook. Okay, and there you can start writing your coding without any installation. You can just connect, press disconnect. It will connect to an environment, and then you can start type coding. For example, if I want to import the Matplotlib, all the libraries for machine learning and deep learning will be available in the collaboratory. You don't want to install the third-party libraries also. Matplotlib pyplot splt, so it will run it without fail because uh, the environment uh, has these libraries: Matplotlib, Numpy, Pandas, Seaborn, and Keras for deep learning, and scikit-learn for machine learning. So all this library uh, in this collaboratory you can find. Okay, now if I type import matplotlib dot pyplot as plt, so this one also will run without fail because uh, this environment has this library anaconda environment. So you can see successfully it's run. I will just okay. Now let's start our session today. So today we'll see the libraries numpy, pandas, matplotlib. Okay, So first we'll see numpy. Sample 17. Okay, now so first you want to import the numpy library. So what is numpy library? Numpy library is, the name is numerical python. So all the numerical calculations and array operation, so we have a concept of array in python also using this numpy library. It's called numpy array. So you can use the numpy for arrays, or you can say numerical calculations. It will do faster than others. Okay, so let me create an array first using the numpy library. So to install, to import it, just simply import numpy. Just an alias name np. Okay, so we'll call numpy as np only. The name is np. Okay, now let's create an array a. So to create array np dot, we have a function called array. So this function will create an array. So array means not a single dimensional, it can be multi-dimensional. Okay, so first I will give single dimensional 1 2 3 4 5, like that. Okay, now it's a single dimensional array. Okay, now I will print this array a. So to run this you can press F5 also. The output will be shown in the console. Okay, 1 2 3 4 5 here. So and then I will create a two-dimensional array b. To create two-dimensional array, you want to give the list as a two-dimensional. Okay, so create a list, and inside that we'll have a row column. Okay, so we'll give the first row 1 2 1 comma 2 comma 3 comma 4, and then the second column will be, second row, sorry, 5 6 7 8. Okay, now you can observe we have two rows. This is first row and this is second row. We have four columns. Instead we have four values, right? So we have four columns. If you print b, you will see the ordered array. It will order itself. So you can see here. Okay, so we have two rows and four columns. This is how you can visualize the numpy array. And now let's compare the list in python and the array of numpy. Okay, so actually numpy array is more efficient with when compared to python's list, because the size of array is very lesser than the list, and the execution time it is very less from the when compared to list actually. So I will show you that. So first let's see the size of these two, list and array. So first let's create a list. For example 1 2 3 4 5, we'll compare with the a array. Okay, so I will print the size of a. To print the size of a, the array, the a array, you want to do like this: len of a multiplied by a, sorry, np dot size, or you can say a dot size. We have a attribute size. Okay, it will give you a size of each element. Okay, so the size is 25. Let's see the size of list. To see the size of list, you want to import a library sys, and you can print the size sys dot get size of the list. Okay, see, there's a difference, right, from the list and array. So the size of array is 25, the size of list is 96. So uh, from the when compared to the size, the numpy is very efficient than list. So now let's compare the performance. Okay, let's say we're having two arrays, we are going to add the two arrays or two lists. Okay, we'll see the execution time, what time it takes. Using that, you can compare the performance of this array and list. Okay, now let's do for the first array. Okay, let me create an array a. Okay, so we'll create 1,000 values. Okay, np dot 1,000 values. If you want to create, you can use a function called arrange. Okay, arrange, it will help you to create 1,000 values, say 10,000 values. Okay, 10,000 values will take. Np dot arrange of 0 to the same 10,000 values. Okay, so now what we are going to do is we are going to add these two arrays a plus b, that's it. So we'll check what is the time it takes for adding the values, and we'll print the time. To calculate the execution time, we'll use a module called time. Okay, so before starting the addition, we'll store the time. Start equal to time. It will give you the current time, and then after addition we will end the time. We'll calculate the end time. Time. Okay, now we have the starting time and ending time. After the execution we'll have the end time. So let's see the uh, time to add time the array takes to add these two arrays. Okay, print end minus start, we know that, end minus start. So it will give you milliseconds. To convert that, we'll multiply with 1,000. Okay, so let's take the time for array. The time is 0.84 seconds. Okay, now the same thing we'll do for what list. Okay, we'll check the performance for the list. So to create 1,000 values, 10,000 values for list, we want to use the range function, right? Range of 0 to 10,000, and the same list of range of 10,000. Right, so now the same will calculate, but we don't to add these two list. Okay, you can't do like a plus b, it is different from the array. So you can add these two arrays with simply a plus b, but you can add those list with a plus b. So for that, what we need to do is I plus j for I comma j in zip zip of a comma b. This how you will add these two lists. Okay, in for the list you will add like this, but array itself if you use a plus b, automatically it adds those values. Okay, now let's calculate the time for list. So you can see here for array is 1.0 and for list is 21.13. Okay, so this has a major difference for list and array. So mostly all these AI algorithms uses a numpy array only to store the data actually. Okay, whether it can be deep learning, whether it can be machine learning, we store the data as a numpy array. Okay, not a list one actually. So that's why it is efficient from the list. Okay, now let's see some functions on uh, array. Okay, the shape is a attribute actually, it's not a function, it's an attribute. It will give you the shape of the uh, array. Sorry, not list actually, it is overriding actually. I will copy this b, paste it here. So now b dot shape, so it will give you the shape, means how many rows we have, how many columns we have. That's the shape contains 2 rows 4 columns. Okay, now we have some other functions also. uh, Print b dot size, we all know. So size will give you the size of elements, each and every elements. What's the size? The size is 8. Okay, for every elements. Okay, and then we have the shape, we know that, right? 2 comma 4. Can we change the shape? Can we reshape it? Yes, we can reshape it. So using the function called for example b dot reshape. So till now it is 2 comma 4. I will change 4 comma 2. Okay, I will change 4 rows 2 columns. Okay, so now we have 2 rows 4 columns. I will reshape into 4 rows 2 columns. Okay, let's see now it is reshaped to 4 rows 2 columns. So you can reshape a array. Okay, so you can let's see some mathematical calculations of these arrays, like addition, subtraction, division, like that. So I will create another array a as a two-dimensional only. A, this will contain, okay, the same values a and b contains. Okay, now let's see a plus b. A plus b, so what it will do, the a plus b will add the corresponding elements. Like first question, what is the value here? 1. On the b, the first question, what is the value here? 1. So it will add these two values, 1 plus 1, right? Like this it will add the corresponding elements. Okay, you can see here 2, 4, 6, 8, 10, 12, 14, 16. So 1 plus 1 2, 2 plus 2 4, 3 plus 3 6, 4 plus 4 6, 8, like that. And the next row, 5 plus 5 10, 6 plus 6 12, and then 14, and then 16, like that. Okay, now we can subtract it, a minus b. Okay, now if you subtract these two elements, 1 minus 1 0, 2 minus 2 0, 3 minus 3 0, 4 minus 4 0, so all this will be 0. That's why the values are 0. Now let's multiply A star B for multiplication. So now 1 into 1 1, 2 into 2 4, 3 into 3 9, 4 into 4 16, right? 5 into 5 25, 6 6 36, like that. It will multiply the corresponding elements. And for division also, A slash B for division. Okay, it will divide it. So 1 by 1 1, 2 by 2 1, 3 by 3 1 actually, 4 by 4 also 1, like that it will divide corresponding elements. So these are the mathematical operations. Now let's see, for example, some functions like minimum. A dot min max min function also is here. So minimum function will give you the minimum value on the axis. Okay, if you give the axis none, it will take axis as row. So you will see this. So it is taking, actually, okay, if you don't give axis means it is checking for the whole array. Let's say if I give axis equal to 1 or 0 for rows, so it is giving, oh, it is column, huh? Okay, so axis 0 means column, so it is giving me 1 2 3 4. That means it will calculate the minimum of these rows. Okay, sorry, columns. The first, it will take the first column, and then for every like every rows, it will take the first row first column, and the second row first column. So what is the minimum here? 1 is the minimum here. Like that, the second, first row second column, second row second column. So what is the minimum here? 2, right? Like that. If you put 1, it will be rows. So it is giving me 1 and 5 only, because it's taking this first row. And what's the minimum value here? 1 is minimum value on this row. So it will take the next row. What's the minimum value here? 5 is the minimum value here. So this is how you can use the axis. Like the same way, the maximum is a dot max. Okay, and then we have a function called a dot sum. Okay, sum means it will add all the values. So if you just give sum and axis is none, so it will add all the values. Okay, let's see. So the 36 is the sum of all the values here, 1 2 3 4 5 6 7 8. If you give axis, let's see, axis 0, so we know that it will add by columns, right? It will add the first row first column, and the second row first column. It will be 6, 1 plus 5 6, and then 2 plus 6 8, right? And then 3 plus 7 is 10, then 4 plus 8 is 12, like that it is give you. Okay, these are the sum functions. And then we have the mean and standard deviation. If you want to find the mean and standard deviation, like a dot mean, we have mean function to calculate mean, uh, and a dot std for standard deviation. And we have log. Actually, you can take log. NP in the Numpy module has the logs, like log 10 base 10, uh, like log 5. These are logs. The normal log will take log of a. Okay, so you can see the mean is 4.5, the standard deviation is 2.29, and the log of every values, log of 1, log of 2, log of 3, log of 4, like that. Okay, these are the functions of NumPy library. So this NumPy library has other functions also, like random. This in this function, you can create some. You can calculate the random numbers, or you can uh, create a distribution, random dot uniform uniform distribution. If you want, the uniform function will be used for that, or some other distributions like normal distribution, random dot normal. Okay, like you can create a distributions also using the NumPy library. Okay, okay, now uh, that's it for NumPy library. Now let's move on to the next library. We'll see Matplotlib. Okay, so we'll see Matplotlib. So Matplotlib is a library for data visualization. Okay, if you want to visualize the data, if you see raw data, you can't get any idea. If you put some graphs, you will get a better idea on the data set. So that's why we use Matplotlib, our Seaborn library. These two are some visualization tools. Okay, let's see. First we'll see Matplotlib. So import the Matplotlib, matplotlib dot pyplot pyplot as plt. Okay, so alias is plt. Now we'll use plt only. So this library contains various graphical charts, like line chart or bar chart, histogram, pie chart, and scatter plot. These are the types of plots. Okay, so for different data types, we have different plots. For example, let's see the simple plot, plt dot plot. It will give you a line plot. You want to give some the coordinates x and y. For example, I'm giving 1 2 3 4, and I'm giving here, say the same 1 2 3 4. So it will create you a simple line. To show the plot, you want to give this function show. Okay, that's it. These two lines will create a plot. Let's run this. So the plots in this spider, you can see it in the plots tab here now. So this one is a simple line plot. Like, okay, you can modify this plot also. Like you can give the grids also. To give the grid, you have function plt.grid. So it will give you the grid one. So you can see the grids, right? Okay, now if you want to change the color of this line, you can change the color. Actually, we have a parameter c equal to, will give other name, like for example r for red. Okay, we'll see. So the line color is changed. You can change the width of the line also. So to convert the width of line, you can use the line width parameter. Here the line width, I'm just giving 4, let's say, or 3. Okay, so now the line is thicker than the previous one actually. So you can see the difference. Okay, now the axis is not labeled, x-axis and y-axis. To label the axis, you want to use a function called xlabel for labeling the x-axis, and for labeling the y-axis, you can use the y-label. Okay, so these two functions will label the plot. So you can see here now this label in the x-axis and the y-axis. Okay, if you want to give the title for this plot, you can give it using the title function. Title for the plot. Okay, title for the plot you can give in the title function. Okay, so now you can see the title, you can see the grade, and now uh, see the first one we created a simple plot. Now we customized the plot like this. We put the grid and we label the x-axis and y-axis, and we gave the title for that, right? This is how you will create the plot using Matplotlib. We can create multiple lines actually. Let me create another one. So this plot function, as we know, it will create a line. Okay, so you can give some markers also. That means what are the points are, this one is a simple line, but what points we are used here now, 1 2 3 4, that should be marked. To mark that lines, you have a marker equal to, let's say I'm using O, it will put a dot there. Okay, like O, see that. So you can see a dot here now. So these points are marked. Using these points only the line is created. Okay, now let's create another line. Built dot plot. We'll start with 2 4 8 and 10. Okay, and we do the same, 2 4 8 10. We give the color a different color. Okay, we'll give mm, yellow. Okay, and the line width is the same, and we give a different marker. Now the marker will be hyphen. Okay, or okay, let's put dot only, it will be visible for us. Okay, now you can, we have a different lines, you can see it in the plot actually. Okay, oh, it's overriding it. Let's give some random values. Okay, so the lines are, now we are having two lines here. So this is the first line, this is the second line. You can give a name for the lines also. What the line is denoting, what this line is denoting. You can give the name, the label. The parameter is label here. So you want to give the label equal to the name. Line 1, let's say. Line 1 is the name of this line. And the second line is label equal to line 2. Okay. Now we have these two lines named. So the name should be shown in the plot. To show the names, we can use the function called legend here. Legend. This function will show that names. Okay. Now let's run this. We will see here the names of the line 1 and line 2. Okay. Now the plot we are created like this. Okay. Grid we put grid and label the axes, give the title. If you have too many lines, you can give the names also. Okay, this is how you can customize the Matplotlib from a simple one to uh, a beautiful plot. Okay, now this Matplotlib have various uh, charts, like this simple line chart. we have a bar chart also. Bar chart will help you to use the if you have a categorical type of data, we'll use using the bar chart. Let's say for example, the x would be uh, the categorical types. For example, the subject, let's say subject 1 and subject 2, subject 3 and subject 4. Okay, these four subject we have, and then we have a height parameter here. Okay, the second parameter would be the height of these bars. Okay, the subject 1, the values is 89, 78, 67, 90, like this. Okay, and then that's it. It will create a bar chart, and then you can give a title, you can give a label. uh, okay, and then we can show the plot. Plt dot show. Okay, now this is the bar chart. Okay, you can change the color also using the C parameter right here now. So you can change the color. Okay, now and then we have a type of histogram. Histogram is the same as bar chart, but it's different. It use a numerical type of data for that. Okay, it will not use a categorical type of data. Actually, in the bar chart, the bars will be the same width and same spaces. You can see it has the same space and same width. Okay, height may vary, but width is same. But in histogram, it will be different from the bar chart. Okay, so the histogram uses a numerical type of data. For example, let's say numbers equal to will create a 100 numbers, for example random numbers in p random integers will create random integers from 0 to 100 will create for 100 times. Range of 100 times will create, and this 100 times will plot in the histogram. We have another parameter, that is bins. Means nothing but the range of one bar. Okay, so the first bar is the range 0 to 25, let's say, and then the second bar will be 25 to 34, for example. I'm giving. Okay, okay, this is how you can give the bins. Okay, and that's it. And then you can label the axis, you can give title and then show the plot. Wait, sorry, range. So you can see this is the histogram actually. So you can see there is no space between the bars, and the width is varying. You can see this is a bar actually, but the width of the bar is very small, so that's why it is not showing here. So this is how the histogram will be look like. Actually, to make it a beautiful plots, you can use a Seaborn library. Actually, import Seaborn as SNS. I will import, and then we'll set a uh, style for this plot. SNS dot set style. So let's say I'm putting white grade. We have white grade, dark grade, uh, white or dark, like that. These are the styles. If you put white grid now, the plots will be very beautiful. Actually, automatically it will change. See the white grid, it is different from the previous one. Actually, you can see the plots, right? These are the previous ones, Now see these ones. Okay, so we are using the white grid style. If you put dark grid, it uses the dark style. So this is the dark style actually. Okay, okay, and then we have a another uh, chart type, plt.py. So you know that pie chart, right? So it helps you to compare a thing on the whole group. If you have for example marks and subjects are a good example of the pie chart. So first we'll give the subjects, subject 1, these subjects and the marks. Okay, okay, and then and then you can show it, plt dot show simply. Okay, now we want to run these two lines only. To run the selected lines you can run this by via, wait, I think we want to give this next. Okay, wait, so the parameters we'll see. So if you don't know about the uh, function, you can press control I, and then it will show you the uh, the parameters that are here. So x, it will be the values, and labels parameter we need to give. So here we need to give labels. Okay, in the labels only you want to give the labels for the uh, part, the categories, subject 1, subject 2, subject 3, like that. So now we'll see the plot. So you can see here the pie chart. So the percentages are not showing here, right? So to show the percentage you can use the here auto pct parameter here now. This parameter you can use auto pct equal to, you can give a format like this, percentile and percentile 1.2f, and then percentile is how you want to give that. Okay, so that means we'll show two decimal places of the percentage. That's what the 1.2f is. So you can see here two decimal places are showing now. Now you can also explode a part, a piece from the pie chart. So let's say if you want to explode this subject 2 from this pie chart, you can use the explode parameter. So I will take it here, explode equal to, you want to give this one 0 comma 1 comma 0 comma 0. So how I do this is, I want to explode this part only, right? So the subject 2 is this one. So that only give 1 and then other will give 0. So that part only will explode. So you can see here, right? So this is how you can create a pie chart. So now let's, for examples of Seaborn, I will just show you. I have already created. So the Matplotlib and Seaborn on both, the concept is same, visualizing the data, but uh, the Seaborn is very like attractive one actually. I will show you the plots of the Seaborn. It's very attractive one. So you can just import it like this now. Import Seaborn as SNS, and then the SNS module contains some functions, you can see if you press control space it will show the options. If it doesn't show these options, you can press control space, it will show this list of functions and attributes. Okay, now you can see axis dist plot, heat map, bar plot, box plot, and KD plot, count plot. These are the type of plots available in SNS, the Seaborn. Okay, pair plot, like the simple plot one, factor plot, violin plot. So these are the functions. Okay, I will show that. Wait, here that is. So we can open with the collaboratory. So I used a data set actually, the Titanic data set. Using the Titanic data set, I have just created some plots using the Seaborn library. So you can see here sns.dist plot. Okay, so don't worry about the data of age. So we'll see that after this Seaborn, we'll see the pandas library now. Then you will understand what is this. Okay, so sns.dist plot will give you like this plot. So it has the histogram and then with the a line. Okay, is the dist plot. If you don't want the histogram, you can just simply say hist equal to false here, hist equal to false here. So it won't show the histogram, it only just show this line only. Okay, this is a dist plot, and then we have a scatter plot. Scatter plot is like it will just put a dot where the point is. For example, if you have 1 comma 2, if it will put a dot in the 1 comma 2. Okay, like that it will put all the datas. So I have taken x as age and y as far, and the data I'm giving as a pandas data frame, and then it will create me a scatter plot. Okay, a single line only you can just create a plot. Okay, and then I have created some other plots also. So you can see here factor plot. So factor plot used to create like a bar chart only. Okay, it takes a column name survived. Okay, now the data I'm giving the pandas data, and kind that is count. So that means we are just going to count the survived class. In this survived column we have two classes, 0 and 1. We are going to count it. So how many zeros are there, how many count sorry 1 are there. So the factor plot will do that, and then we are just putting a title. Okay, and then the plot is showing. Then we have a cat plot also. If you have multiple uh, categories over multiple categories, so we have survived 0 and 1, and we have sex male and female. So you can create a cat plot using x as sex and hue as survived. Okay, hue is nothing but this legend is showing here now, survived 0 and 1. That is the parameter for hue. And kind is count. We know that we are going to count how many males are survived, how many males are not survived, how many females are survived, how many females are not survived. Okay, again we are giving the data as a pandas data frame. This is the example of cat plot. Okay. Okay, that's it for Seaborn. uh, Now we'll see pandas. Okay, pandas is a library for managing the data. Okay, for uh, creating a data frame, it's called pandas data frame. So usually we have a two-dimensional data. If you have, then you will create a pandas data frame. Okay, so in pandas allows us to create a three-dimensional or two-dimensional or one-dimensional. One dimensional is called series, 2 dimensional is called data frame, 3 dimensional is called panel. Okay, so so before that, let me save this file, sample 19. So first you want to import the pandas library. Import pandas as PD. So you can do various operations, transformations, cleaning, or handling the categorical data. All the stuffs you can do with the pandas library. So let me create a series. First, the for one-dimensional data. So s equal to PD, and the alias is PD. Okay, and then here in the PD pandas library we have various functions. So we have a function called series. Okay, that's a class actually. And then here you want to give the values, for example 1 comma 2 3 4 5 6 7. So this is a, in this series you want to give only a same type of data. So here I'm giving integers, so all the values should be integers. We want to give a d type here. D type equal to, so we'll give integer np dot int 32 or int 64, we'll see. Okay, and then let's print the series. So this is how we'll create a pandas series. So this the result will be like this, you can see. So the 0 1 2 3 is nothing but the index value. Okay, index, and the values are 1 2 3 4 5 6 7. So and then the data type is int 64. If I change the type, let's see, float, 32 I'm changing, float 32, then you will change in the value 1.0, 2.0, like that. Okay, so the series contains the same type of objects. Okay, now you can also create a series via a dictionary also, like this. So first we created a series using list. Now we'll create using the dictionary. For example, you can create like this. Subject 1, the mark is 89. Subject 2, the marks is 78. Subject 3, the mark is 67. Subject 4, the mark is 56, like that. Using the dictionary we are creating. So see here, using the dictionary we are created. So if you create using the dictionary, the you can set the index. Okay, so the index usually it start with 0 and 1. If you give it the dictionary type of data, it will take the key as index value and the value as the value only. Okay, so like this it will create. Or else if you want to change the series index of this one, the first one, if you want to change the index, we have a parameter called index parameter. In here we can give the values, index values. Okay, okay, so this now this is the one dimensional data. Now we'll see two-dimensional data. If you have two-dimensional data, that's called a data frame, pandas data frame. So you can create using pd dot data frame. Okay, in this data frame you can give this in two formats. One is using the list, or other one is using the dictionary. So first we'll see with the list. Li equal to, so pandas data frame is two-dimensional, so the list will be two-dimensional. For example 78 comma a, like 67 comma B and then C 45 comma D. So this is the two-dimensional data. Now we are going to convert the two-dimensional data to pandas data frame. So here we are giving two columns, right? So these two columns needs to be labeled. So you can give the label here in the index. Actually, give the index equal to, the first one is marks, let's say. The second one is grade. Okay. I'm going to print the data frame. Sorry, I think that is columns, I think. If you are assigning the index parameter in the series, you want to give the same length. Okay, that's what the error is actually. Now you can see here is the data frame. In the data frame, we have different types of data. That means rows, for example, it can have integer. In this rows, it can have characters. So like that, it has many data types on the data frame. Okay, is a two-dimensional. You can create using the list like this. Okay, so we have two columns, marks and grades. We are given here columns names. Okay, now we create using the dictionary. To create with the dictionary, so like this, you want to give us a dictionary. So the first will be the uh, column name. For example, marks is the column name, and then you want to give the values for the column, that is 78, 67, like that, and 56, 45. So you want to give the column name and the values of the column. And then the second column is grade. You want to give the values for that. The values is A and B, C, D, like that. Okay, now we'll print the name as df2, print df2. Okay, so you can see here the same output. These two are the same, just we are created using the list, or else you can create using the dictionary. Okay, now what about the files? If the data is in the file, how we can read? Okay, so pandas allows us to read from the files also. For example, I'm creating data equal to pd dot. Here if you put a read, you will see many functions: read csv, read excel, or read hdfs, read html, read table, read pickle. These are the functions which will read from the files. Okay, for example, if you have csv, uh, read csv. Now you want to give the file path. For example, uh, I will give a path. Wait, maybe you can go to the files here. So here only you can go. There it's the data sets. Okay, now we'll take this data, copy the path and put here. Then it will read the data. you can print the data. No, see this the data inside the uh, file read csv. Okay, data.csv, inside the file we have this data. Okay, now this data frame allows us, like, if you want to count like how many nan values are there. Nan values are nothing but the empty values. So you can do like this: data dot is in a dot count dot sum actually. So it will give you, so in age column we have one nan value, in salary column we have one nan value. So if you put data dot info, it will give you information about the data. Like we have four columns: country, age, salary, purchased. So in the country we have 10 non-nun values. The type is object. Okay, and then we have age column, 9 non-nun value. The type is float 64. And then we have salary, 9 non-null value. We have the type is float 64, and like that it will show you for all this. And we have another function, describe. Describe will tell you the count value and mean, standard deviation, minimum, 25th percentile, 50th percentile, 75th percentile, and the maximum values. So using these are like you can say a descriptive statistics. So using this function you can get the information about the data set. Okay, and then now let's see. For example, we have country, age, salary, purchase. Okay, now we can give some queries also. Queries means, for example, I want the data correspond in the country France. Okay, so I want the data for only the France. So that will be a query. Okay, so the queries you can write like this. For example, let me create a France variable. So this will contain all the France data. So to do that, we can simply say data brackets, and inside the brackets, uh, the one thing you can give as a country. You can, if you give data of country, it will give the single column, the country column. Now we want to uh, give some conditions, right? So the condition is like this: data of country where the country is equal to France, take that data only, right? So here, this is how you can do that. You can write a query. Now if I print the France, all the data will be France data. See here, so all these are France data only. Okay, now let's say I want the France data, but the purchased will be yes. Okay, see, I'm just telling country equal to France and purchased equal to yes. This type of data I want. So how can you do that? So you can do that, yeah, like this. So you want to put a brackets. This is the condition one. So the operation is and, like, and okay, we have the country should be France and the purchase is yes. So the operation is and. We can put and symbol and another brackets. Inside that we want to give another condition, that is data of purchased equal to yes, right? Now you will see the country equal to France and purchased equal to yes. These three only. Okay, this is how you can write some queries and you can filter the values. Okay, you can also group by the value. For example, grouped, I say grouped equal to, let's say I'm going to group by the country name. Group, sorry, group function we have group by the column country. Okay, now it will give me the grouped value. See, oh sorry, if you want to take the if you want to see the uh, data inside the grouped value, you can simply say head will take the first values. For example, I am giving head of 10, so it will give me the first 10 values. So now this is the grouped one. uh, like first, wait. Okay, you can see now the grouped dot count. If you put the France 4 values, Germany 3, Spain are 3, like that you can do. Okay, this is a group by. Now let's say in this column I want to select these two columns only, age and salary. How can you do that? We are like this: print data of. So we have two functions, lock and ilock. So these two functions will help you to fetch the data, the corresponding rows and columns. Okay, if you are using the lock, you want to give uh, the labels as the labels. That means all the values you are giving here na, that are labels, that not index values. Okay, 0 and 1s, like that. So what you can do is these are the rows and these are the columns. Let's say, okay, first we want the rows. In the lock method, you want to give two values, rows and columns. Let's say from 0 to 5 columns. Okay, 0 colon 5. So okay, sorry, that is rows actually. So 0 to 5 rows, and then the columns are, I want these two columns only, age and salary. We can do like this, or you can say brackets and give the column names age comma salary, or you can say like this, age colon salary. So this will be a slicing like that. So all the values you are giving in the log, that is a label. So 0 to 5 is a label and age to salary is a label. Okay, now let's see. Yeah, we missed the parenthesis, square brackets. Yeah, so here you can see we are having these two columns, age and salary. The labels are from 0 to 5 rows. Okay, this is the use of lock method. Another method we have ilock. Ilock is simply index location. All the values are here that are index. You can't give age and salary. You want to give the index of the column. For example, if you have age, so you want to give the index of age, that is 0 and 1, like that, 1 and 2. So you want to give like that, as an index only you want to give. For example, 0 to 5 and 1 colon 2 only you want to give. So this is row and this is column. The column you can't give as a uh, names in the ilock, just you want to give as a index value. Okay, and one more thing, in the index ilock, no, it won't take the upper bound. Okay, if you want 0 to 5 value, you want to give 0 to 6. If you want 1 and 2 columns, you want to give 1 column 3, then only it will give you 1 and 2 columns. Okay, first question and second question columns. So this is how the two methods you can retrieve the data, log and ilog. Okay, and then in the pandas data frame also, it allows us to create plots simply using the plot function. Directly you can create a plot. For example, kind equal to let's say bar chart. Now it is created the bar chart for the columns age and salary. Because other columns you can also I think give the columns actually x. Let's give x equal to country. Okay, so now it's taking the country column as the x-axis. So France, Spain, Germany, like that, and it is putting for age and salary. Okay, age is not showing here. Wait, maybe okay. Let's see some other one. Pie chart. Simply see, simply plot what it is giving. Okay, simply plot means it is just giving a line plot. Okay, or else you can give some kind histogram or like that. Hist. So now it is a histogram for age and salary, like that. Okay, and we have a last concept we'll see. The concept is data munging. So data munging means if you have a data frame, pandas data frame, you can read it from any file. You can read from CSV file, Excel file, or any file. Okay, now we are created a data frame. So data munging is you can distribute the data as a different types. For example, we have this data frame. If you want to convert the data frame or you want to store the data frame in a file, for example data dot to, if you put, so you can see some functions to CSV or to more functions is there for uh, to HTML also. Yes, to HTML you want to give a name and then it will store as a HTML file, or you want a Excel file, you can create an Excel to Excel data dot to underscore Excel. This is the data munging actually. Okay, now if you see sample.html, so now it will create, it is generating a table. Okay, I think we can visualize this. Yes, any doubts? I will open the HTML file in a browser, then we can visualize the table. Sorry. here. So this is the table here, the pandas data frame. It is converted to HTML table. Okay, or else you can convert it to Excel file also. Any type of data you can convert. Okay. Okay, I think we can end this session from this. Any doubts you have, you can ask. Any doubts? Okay, I hope no doubts. So we are bigdatahandson.com, our website bigdatahandson.com. So you can visit our website. This is the today the day is 14. So the previous videos will be uploaded in our YouTube channel. If you subscribe to our channel, you will get all the updates. So this is our YouTube channel bigdatahandson.com. So you can see yesterday's video and all the previous videos you can see here. So today's we will upload as soon as possible today's video. Okay, so if you have any doubts, you can message us in this number 978988424, or you can email through this support@bigdatahandson.com. Okay, we'll see tomorrow. Actually, from tomorrow we are going to start machine learning. Okay, so let's see tomorrow.